Good afternoon, everyone. I am Rebecca, and today with my colleagues Ben and Rupert from Bank of England, we will be presenting you evidence on flooding risk occurrence and distribution across UK corporates and their impact on their business operations. We are doing so by integrating flood risk maps together with highly granular business addresses, premises data, and corporate financial accounts. But before proceeding, let me start by thanking the HMT Economic Innovation Fund, DEFRA, and Ordnance Survey for their financial and technical support to this project, and also by reminding you that these are our own personal views and in no way represent those of the Bank of England or to state Bank of England policy. So you may wonder now, why does a bunch of economists care about flooding? Well, flooding represents the largest source of physical risk from climate change in the UK. And as you can see from these charts here behind me, the incidence of flooding has been in England and Wales has been much more widespread in the last 20 years relative to 20 years prior. And a variety of sources project an increase in frequency and intensity of precipitations in the decades ahead, and therefore the risk of flooding associated to that as a result of climate change. So today, in the UK, flooding already costs around 1.4 billion on damages yearly to the UK budget, and 0.8 billion on adaptation investments, adaptation spending. But flooding does not represent just a cost to the budget. Flooding represents disruption to economic activity, to production, and loss of wealth. So I think you can already start to appreciate how does this have important implications for the future of UK productivity and growth in the UK, and therefore the consequences associated for monetary policy and financial stability.
So we have data sets with business information and flood information. The first of these data sets is address-based premium, and that provides address information for properties in the UK. There's an indicator for property type, so whether the property is a retail store, a bank, a university, a residential premise, etc. It's also got the centroid coordinates for the property, and this is, of course, really useful for figuring out how businesses locate in the country. But we need to also know the expanse of the property, and this is where the energy performance certificates and the buildings data set, also by Ordnance Survey, come in. We also have Bureau van Dijk Fame, which provides annual balance sheet information and a sectoral classification. And we've got Experian, which is SME, monthly, current and borrowing account balances. On the flood information side, we've got historical flood maps, and from a more forward-looking perspective, we've got flood risk zones for rivers and sea, which has got an indicator for flood risk, taking the value of low, medium, or high. And then we've got an indicator for flood defense coverage. So I just want to emphasize a little further how important address base has been for our project. And this is what it would look like if you visualized it on a map. It was put together by Ordnance Survey. And you can see here it identifies every property in a given location. The scatter points, the ones in white, identify residential premises, the ones in green, commercial premises, and then on the legend on the bottom left-hand corner is a more granular property classification breakdown, and that is the color of the properties that you can see. On the top right, you've got some more information there, so you can see organization name for this one property, which is Pizza Express in Warwick. And organization name is really key for us to link it in with the other business information data sets that we've got. And as you can see, we have the other information here, including the property centroid coordinates. So how do we actually link these data sets together? So we've got the centroid coordinates, we've got the floor area, but using these together with some basic maths, we can calculate the radius and a circular estimation for the property. And then we can overlay flood maps on top, which then we can calculate the area flooded of property, and then that feeds into regressions that Rebecca will discuss in a bit. So we do much of this merging locally in R with the SF package in particular. More recently, we've been exploring the use of Apache Sedona, which is a cluster computing system for processing large-scale geospatial data. It runs atop the Apache system, and there's APIs in R and Python and other programs to allow you to run it. And we've been really impressed with the performance improvement that we've seen with Sedona. You see here reading a CSV, creating a buffer, and running a spatial filter. The improvement in performance has been about tenfold compared with SFNR. So we're really keen to continue to use Sedona for large-scale geospatial analysis in the bank.
Now, as all of our data merging was done in R, it was only natural for us to create data visualizations using a well-known package called ggplot2. So here's a few examples of what we've created, starting with the map on the left, which shows the proportion of business premises in areas that have been previously flooded since 2011. Now, we chose to use hexagons to visualize this because we just thought they were generally more aesthetically pleasing because of their symmetrical properties, and each hexagon represents about 500 square kilometers, which is roughly the size of central London. Now, looking at the map, you can see that the areas with the highest proportion of flooding is the northwest, mainly that Cumbria region, but there's also some darker hexagons in the southwest region and also around that Yorkshire area as well. If we switch our attention to absolute numbers, so the map on the right, which shows number of business premises in previously flooded areas, which is also being separated by industrial classification, we can see a bit of a different story where the darkest hexagons are actually in that Yorkshire area, mainly around Leeds. And if when we did some more analysis, we noticed that over the past 20 years, around 1% of business premises have been flooded in the UK, but that increases to about 6% for the Yorkshire and Humber region. So if we build upon this analysis from historical exposure and start looking at forward-looking exposure, the map on the left shows the proportion of business premises with flood defences. Now, we wanted a bit more of a granular view of the data here, so we decreased the hexagon size to around 20 square kilometres, which is about double the size of London Zone 1. And if you went off our previous maps, what you'd probably anticipate is that the Cumbria region, that Yorkshire region, would probably be the most fortified. But when we actually plotted the data, we noticed that the east coast of England was actually the most heavily protected, especially the sort of Norfolk, Cambridgeshire, Lincolnshire area. And this trend makes a little bit more sense when you actually look at flood risk. So the map on the right shows the proportion of business premises with medium to high flood risk, and once again split by industrial classification. And you'll notice that the darkest hexagons are actually in that east coast area, mainly around the Lincolnshire and Norfolk area. So in order to verify our results and gain a greater insight into flood risk in the UK, we wanted to create some more detailed visualizations using Carto. So here should be a quick demo showing how easily we can merge our data sets together and validate our exposure of firms. So the first thing that we do, we add the organization data in. And this is centered on King's Lynn, which is that one of those high-risk areas and high flood defense areas that I've just been talking about. Now, we can add in certain features to make the map a bit more insightful. So what we're doing here is changing the color of the property based on whether it's a residential property or a commercial property. And we're going to change the size of each point based on the number of total assets of the property as well. And then when you zoom in on King's Lynn itself, you'll notice that most of the properties are actually on the right of the river, and this is the town centre. So the second layer that we're going to add is the flood risk maps for the whole of the UK. And then we recenter on King's Lynn, and you'll notice that that town centre area hasn't been overlaid by any flood risk maps showing the presence of a flood defense. Now, with Carto, you can also add in SQL queries. So here we're going to filter on just medium and high flood risk. And then once you filter back on King's Lynn, you'll notice that it hasn't been, the town centre still hasn't been overlaid. And just as before, just to make the map a bit clearer and a bit more insightful, we can change the color of the map so that the high risk areas show up in red and the medium risk areas show up in blue. And the last thing that we do, just to validate our results, we want to add in an interaction so that when we click on a firm, it actually comes up with a bit of information. So the information that we're going to add is the name of the firm, the industrial classification of the firm, and also the size of the property, size of the organization based off total assets. So just as an example, we're going to click on a firm in this medium risk area, and the information that we expected comes up like so.
Thank you. So let me now finish by presenting you the main analytical results of our regression analysis. So through a panel data approach, we find that flood risk is in very large part explained by region and sector-specific structural flood risk exposures, such as proximity to water courses, the number of water courses that affect a specific region, and whether water is used in the business itself. But we find also that a large size of a business premise is a significant risk factor in flood risk exposure. And we posit that this could be driven by a search for cheap land, which is often non-arable flood-prone land in the UK. To a Cox proportional hazard model, we study the impact of flooding on the default probability of firms affected by that. And when a flood occurs, we find that SMEs are significantly more likely to terminate their business operations following a flood, whilst large firms are not. They appear to be much more resilient to that. And particularly, it's also recurrence that matters for smaller firms. When a flood reoccurs within 4 years from the original flooding event, we find that the hazard ratio, or the default hazard ratio for smaller firms, increases by 90%. So out of the firms surviving, we studied through a staggered difference in difference regression approach their impact on business operations. And we find that all firms experience a reduction in turnover, employment, and total assets, but with the larger firms surviving and those operating in natural resource sectors being hit much stronger. Particularly, you can see from the chart here that firms operating in natural resource sectors experience more than a 60% reduction in turnover and total assets on the year in which the flood has occurred, and more than 50% reduction in employment. So overall, we find also that in the years following the flood, there is some recovery in these variables. So it is indeed a shock that is much more acute in the year of flooding, and then there is some recovery. But still, flooding appears to be a very significant shock to business operations for those firms that have been affected, and therefore we deem it important to study its implications, especially in light, as we said, of the possible intensification of flooding events in the decades ahead as a result of climate change. So thank you very much for your attention, and if you've got any questions, please email us or find us here.